Hello and welcome to this lesson on setting up storage for Kubernetes clusters. I am Mahendra Mehra, your senior OCI instructor at Oracle University. Let's get started. Picture this. When it comes to container storage, relying on containers root file system is like playing with fire. It's here one moment, gone the next when you delete or recreate a container. To keep our data safe from vanishing acts, we use the concept of persistent volumes. Think of it as reliable, durable space to stash your data far away from the volatile world of containers. Let's zoom in a bit more. A persistent volume is like the superhero of storage, ensuring your data stays intact, even if the containers it's connected to decide to call it quits. Now, to make the magic happen, we bring in the sidekick, the persistent volume claim, also known as PVC. This is our way of saying, hey, I need some space, and the system responds by binding the PVC to a persistent volume. It's like creating a virtual storage connection, abstracting away the complexities. And here's where OCI steps in, giving us options to provision these volumes. We can either attach volumes from the OCI block volume service or mount file systems in the OCI file storage service. And don't forget the storage classes. They allow us to dynamically create persistent volumes without the hassle of setting up storage beforehand. Think of them as wizards behind the scenes, making storage magic happen. So let's get practical. How do we provision these persistent volume claims? Well, we've got two main ways. You can attach volumes from the Oracle Cloud Infrastructure block volume service. We'll dig into the nitty-gritty of that. Or you can mount the file systems in the Oracle Cloud Infrastructure file storage service. We are going to explore that too. Hold on tight. Though we are just scratching the surface here, we'll be unraveling the details in the upcoming lessons. So stay tuned and thank you for watching. Hello and welcome to this lesson on provisioning PVCs, also known as persistent volume claims, on the block volume service. I am Mahendra Mehra, your senior OCI instructor at Oracle University. So let's get started. We are dealing with storage that's not just durable but also offers high performance block storage. Connectivity options are at your disposal. You can utilize either the CSI volume plugin or the Flex volume plugin. Oracle strongly recommends the CSI volume plugin given its ongoing development and advancements. When it comes to storage class for PVC, the choices are clear. Use OCI-BV for CSI, opt for OCI for Flex volume. For clusters running Kubernetes version 1.24 or later, the default storage class is OCI-BV, seamlessly integrated with the CSI volume plugin. In order to provision PVCs on the block volume service, you must establish supplementary policies when the cluster resides in a distinct compartment from its worker nodes to grant the necessary permissions for worker nodes to access block volume service volumes. You must explicitly grant permissions for any user to manage volume in the tenancy where request.principal-type is set to cluster. You must extend permissions to allow any user to manage volume attachments in tenancy where request.principal-type is set to cluster. Considering PVC size, we've got you covered. Any request below 50 GB is rounded up to a respectable 50 GB. Enable PVC size expansion with a straightforward adjustment. You must include Allow Volume Expansion True field in your storage class definition. Cap it off by defining tags during cluster creation for superior resource organization, grouping, and metadata annotation. To create a PVC on a block volume using the CSI volume plugin, you must create a YAML manifest which describes the Kubernetes persistent volume claim. On the screen we have a PVC manifest available. Let's break down the component. API version specifies the API version, which is v1 for the core Kubernetes API. Kind indicates the type of resource, which is persistent volume claim. Metadata contains information about the PVC, including its name, which in this case is my nginx claim. Spec section describes the desired state for the PVC, where storage class name specifies the storage class to be used for provisioning the persistent storage. In this case, it is set to OCI-BV. Access modes defines the desired access mode for the volume. In this case, it is set to read-write once, meaning the volume can be mounted as read-write by a single node. Resources field specifies the requested resources for the PVC. Request here defines the amount of storage requested for the PVC, and storage specifies the requested storage capacity, which is 50 GI, or you can say 50 gigabytes in this case. Once the PVC manifest is in place, you should use kubectl create command and apply this PVC manifest to your Kubernetes cluster. The output of the command will confirm the creation of the PVC. To verify whether the PVC has been created, you can run the command kubectl get PVC. The output of the command will show the current status of the PVC, and by default the status of the PVC will show pending, because the OCI-BV storage class's definition includes volume binding mode, which is set to wait for first consumer. This is a property in the storage class definition that dictates the binding behavior. When set to wait for first consumer, the persistent volume associated with the persistent volume claim will not be bound until a pod that claims this PVC is scheduled on a node. And this setup is particularly useful in scenarios where you want to delay the provisioning of the underlying storage until it's actually needed by a pod. This allows for dynamic provisioning and ensures that storage resources are allocated only when required, optimizing resource utilization within the cluster. You can use this PVC when creating other objects such as pods. For example, you could create a new pod from the following pod definition, which instructs the system to use the my nginx claim PVC as the nginx volume, which is mounted by the pod at the path specified under mount path. I will be discussing the pod definition in greater detail in the upcoming demo. In conclusion, we've navigated through the intricacies of setting up storage for Kubernetes clusters, ensuring durability, high performance, and seamless access. I hope you enjoyed this video and gained valuable insights. Stay tuned for the upcoming demo. See you in the next one. Thank you for watching. Hello and welcome to this demo on provisioning PVCs, also known as persistent volume claims, on the block volume service. Let's dive in. I have already logged in to my OCI console. For this demonstration, I have already set up the kubeconfig file for an existing cluster. I have opened up two tabs. One of the tab is running the Cloud Shell terminal. I'll run the kubectl get nodes command to confirm whether I'm connected to my cluster. From the output, it's clear that I'm already connected to a cluster running 5 nodes within it. I'll clear the screen. I'll switch to my directory where I have all the manifests prepared. And here are my manifest files. I'll open up the manifest for the persistent volume claim. Well, this is the manifest for our persistent volume claim. I've already explained this during the previous lesson. The storage class that we are using is OCI-BV, and the access mode is set to read-write once. And we have defined the resource request for 50 gigabytes of storage. I'll close this file. And let's apply this manifest to our Kubernetes cluster, for which I'll be using the command kubectl create -f and the name of our manifest file, which is csi-bvs-pvc.yaml. I'll hit enter. And it says persistent volume claim name my nginx claim created. We can verify whether the PVC has been created or not using the kubectl get PVC command. I'll hit enter. And from the output, it says that the my nginx claim PVC status is in pending state. And the storage class it's using is OCI BV. And like I explained during our lesson, the PVC has a status of pending because the OCI BV storage class's definition includes volume binding mode, which is set to wait for first consumer. Now let's create a pod that will consume this persistent volume claim. I'll clear the screen here. In the meanwhile, I'll also go to the first tab and open up the block volume storage service. I'll go to the navigation menu, click on storage and click on block volumes. Well, currently in my CTD OKE compartment, as you can see, there are no block volumes created. Let's check the pod manifest file that is utilizing the PVC we created. I'll open up the pod manifest file, which is nginx-pvc.yaml. The API version here specifies the version that the YAML is adhering to. In this case, it's using API v1, which is the core Kubernetes API version for pods. Kind defines the type of Kubernetes resource. Here it is pod. Metadata section defines information about the pod, including its name, which is nginx. Spec field describes the desired state for the pod. Containers specifies the containers that should run within the pod. Name is the name assigned to the container. In this case, it's nginx. Image specifies the container image to be used. And here it is nginx latest. Ports define the port to expose. Here we have named the port as HTTP and the port to expose is port 80. Volume mounts the volume into the container. Name refers to the name of the volume defined in the volumes section. Mount path specifies the path in the container's file system where the volume should be mounted. In this case, it is USR share nginx HTML. Volumes defines the volumes available to the pod. Name assigns a name to the volume. Here it is data. Persistent volume claim specifies that this volume is backed by a persistent volume claim and the claim name is my nginx claim, which we have already created. I'll close this file. Now it's time to apply the pod manifest to our Kubernetes cluster. I'll use the command kubectl create -f and the manifest name, which is nginx-pvc.yaml. I'll hit enter here. And it says pod nginx created. Now if you run the kubectl get pvc command, it says that the status is bound and the nginx claim has been bound to a volume with the capacity 50 gigabytes with the access mode that is read write once and the storage class, which is OCI BV. Now if you go to the first tab, you will see that a block volume service volume has been created of size 50 GB and the default performance for that volume is VPU 10. We will discuss this later on in the upcoming lessons. We can also confirm that the pod is using the new persistent volume claim by entering the following command, that is kubectl describe pod and the pod name, which is nginx, and I'll hit enter. And if you scroll a little up and under the volumes field, you'll find that it is using a persistent volume claim and the claim name is my nginx claim. Also from the events section, you will identify that a volume has been attached successfully to this pod. And CSI prefix over here means that it's using the CSI volume plugin for connecting the volumes to the pod. Also under the mounts field over here, you can confirm that the volume has been mounted to USR share nginx HTML, which is from data that we have defined in the manifest file. With this, we conclude the demonstration where we provisioned a PVC using the CSI volume plugin and successfully mounted a persistent volume of type block volume to an nginx pod running on Container Engine for Kubernetes. I hope you found this demo useful. See you in the next one. Thank you for watching. Welcome to this lesson on expanding a block volume. In this video, we'll explore the steps and key considerations involved in expanding volumes within an OK environment. Let's dive in. When utilizing the CSI volume plugin like blockvolume.csi.oraclecloud.com, you can dynamically increase storage size without any downtime. To enable this flexibility, simply set allow volume expansion to true in your storage class definition. Here's an example. Within your storage class definition, you must set the allow volume expansion field to true. Remember the default OCI BV storage class for the CSI volume plugin